Here we have a SAT math problem. Okay, let's go to the question. If x to the power of 1 over p equals to y to the power of 1 over q equals to z to the power of 1 over r and xyz equals to 1, then what is the value of p positive, q positive, r? Okay, here we have two information. The first information is three quantities are equal, and here the product of x, y and z is equal to 1. Using these information, we have to find the value of the expression p positive, q positive, r. Okay, now let me take the first piece of information, that is x to the power of 1 over p equals to y to the power of 1 over q equals to z to the power of 1 over r. So all these three terms are equal. For example, if I assume 5 as the value of x to the power of 1 over p, then the value of y to the power of 1 over q is also 5, and the value of this one is also 5, because all of them are equal. But I do not know the exact value of each of these three terms. Okay, now let me assume k as the value of each of these three terms. That is, all of them are equal to k. Since all of them are equal to k, we can equate each one of these three terms to k. So first, let me equate this x to the power of 1 over p to k. Then I'm getting x to the power of 1 over p equals to k. Now I can solve for x in this equation. For that, I have to get rid of the exponent 1 over p over here. To get rid of the exponent 1 over p, what I have to do is, I have to raise both sides to the power of the reciprocal of this 1 over p, that is p. Let me raise both sides to the power of p. So then on the right side, I'm getting k to the power of p. Okay, now let me consider the power of a power rule in exponent. That is, we have base a and exponent m. And for the complete stuff, let me consider the exponent n. Whenever we have two exponents like this, what we can do is we can multiply the two exponents. Then I'm getting m times n. Okay, now I'm going to use this power rule over here to get simplified of this one. Okay, now what we have to do is we have to multiply the two exponents over here. Then I'm getting x to the power of 1 over p times p equals to k to the power of p. So here p will cancel out. I'm getting x to the first power. X to the first power is just x. Then I'm getting x equals to k to the power of p. Okay, now I've solved for x by equating the first term to k. Now let me equate the second term, that is y to the power of 1 over q to k, and solve for y. Then I'm getting y to the power of 1 over q equals to k. Now the same thing, to get up the exponent over here, I have to raise both sides to the power of q. Then I'm getting y to the power of 1 over q to the power of q equals to k to the power of q. Okay, now when we multiply these two exponents, I'm just getting y to the first power. Y to the power first power is just y. Then I'm getting k to the power of q. Okay, now let me equate the third one to k. Then I'm getting z to the power of 1 over r equals to k. Now let me raise both sides to the power of the reciprocal of this 1 over r, that is just r. Then I'm getting k to the power of r. When I multiply these two exponents, I'm getting just z to the first power. So z to the first power is z. Then I'm getting k to the power of r. Okay, now let me consider the second piece of information, that is x times y times z equals to 1. Let me write it over here. X times y times z equals to 1. Already we got the value of x, that is k to the power of p. We can plug in this k to the power of p for x over here. And also we know the stuff that is equal to y, that is k to the power of q. Let me plug in that one over here. And for z, we know that k to the power of r equals to 1. Okay, here we multiply three terms with the same base. Whenever we multiply two or more terms with the same base, what we have to do is we have to take the base ones and we have to add the exponents. Then I'm getting p positive, q positive, r equals to 1. Okay, our aim is to find the value of this expression p positive, q positive, r. For that, let me write the stuff on the left side as it is, p positive, q positive, r. Okay, here I'm trying to solve for the stuff that is at the exponent. Whenever I'm trying to solve for an unknown that is at the exponent, so what I need is, I need to have the same base on both sides. When I have the same base on both sides, I can equate the exponent and I can solve for the unknown. Since I'm trying to solve for the unknown at the exponent, I'm saying that we need to have the same base on both sides. So already we have base k on the left side. So on the right side we have 1, but we have to write this 1 in terms of base k, that is as a power of k. So how can we write this 1 as a power of k? So we can write this one as k to the 0th power, because anything raised to the power 0 equals to 1. So the stuff what I have written over here is equal to the original stuff 1. Now look at the base on the left side, a base on the right side. Both of them are same, that is k. Since two terms are equal with the same base k, we can equate the exponents. When I equate the exponents, I'm getting p positive, q positive, r equals to 0. I got the value of the expression p positive, q positive, r, that is 0. We find 0 in answer choice B. The correct answer choice for this question is B.